or more, they pay everything, including your plane ticket and the local expenses. If you visit less than 4 weeks, they pay the local expenses. I think the rule can always be negotiated if you have some way. But roughly, this is the guideline. Okay, the immediate goal for such a center right now is just to finish the physics case for pre-CDR by the end of this year. And in doing this, you can also carry out many studies which are relevant for these two machines, the CPC and the SPPC, and which say, well, what's the reach of new physics or what this machine can do. Okay, the working group in the theory part are divided into these different groups with conveners listed here. In fact, I went to, in my last month, I went there and there was a second symposium. It's just to check their progress. I think many groups are in good shape. I think, in fact, Heavy Ion, somehow they withdraw their presentation, so we didn't see it. One thing from my personal view, one group may need more help is the beyond non-SUSY, beyond standard model group. They probably need some more help. And this is a schedule guideline for such a pre-CDR in physics. Basically, they want to have a very good draft at the end of October, of course, finish everything by December. Okay, in fact, this is what Nima presented at the end of this symposium. Basically, it's one-page argument why China should build such a machine. I won't read it, but basically just say this is just a discovery physics is very exciting, and then in the future of 20 to 50 time scale, we need some new accelerator, and it's a remarkable proposal from China to hold such a machine. It's very, very exciting, and it's do very well physics. It's also a boom for physics to actually engage the ocean of Chinese talent into this field, and so on. It will also help China's development of science and technology, and so on. Okay, let me just stop here. I just want to say, in fact, there's a meeting just at the end of next week, September 12 and 13 at Shanghai Jiao Tong University, discussing about this. If you are interested in knowing more about the machine and the status, you can join that. It's very close. I think it's in China is going. This is if you, you may not want to just listen from me or other people. If you want to see it by your eyes, it's a good chance to go there. So let me just stop here and leave the rest of the time for discussion, I guess.
Okay, thanks Hsin-Chia for the introduction. So now we should go for the section for discussion.
Can we raise questions? Hsin-Chia.
You are panelists, so we need
we are several panelists. We can discuss within panelists or from the audience, or you raise any question to anyone, right? So why don't
let's bring out the chair.
Yeah.
All the panelists. Okay.
So the one who received the email, George and Kaifeng, and also Xiang'an and Xiaogang is not here. Okay, not. Okay.
The chairs I'm not very
Where's the change? Okay, so we bring up the several series and experimentalists in Taiwan and visitors. And so if you have any information or any questions, any confusion, anything, information, you can just bring up and discuss. And
Yeah.
Shannon, why do you start?
One physics question and one non-physics question. About the physics question, you mentioned that if we can have the theory at a very high scale, then we can calculate the Higgs mass. But I wonder, for example, if we want to construct the Higgs the vacuum radiation, we still need to do the measurement. So then the Higgs mass will come in as an input. So I don't understand what you mean the calculated Higgs mass.
Just in a theory, Higgs mass can be finite, right? It can be calculated in that sense. I have the microphone. Certainly, there are models where the Higgs can be calculated with finite mass without any. I mean, there are.
I'm say, so you have something like a string theory, maybe.
Okay.
You can say, but we know maybe
You're saying you always need a new
you always
parameter.
need inputs, right? You always need
input
parameters.
parameters. Okay. In fact, that may be a question about input, whether you think the input parameter is natural or not. If it's order one dimensionless quantity, then it's you may think, okay, it's fine, right? It's just a natural parameter in the theory. Also, in physics, it's always the case, right? We always find deeper and deeper reason. We find a new theory which explains the Higgs, then we may want to find a deeper theory to explain the theory which explains the Higgs mass parameter, right? If maybe you find supersymmetry, you can calculate the Higgs mass in the supersymmetric model. For example, MSSM Higgs mass has an upper bound, which tell you because the quadratic coupling is related to the Ditch coupling, at least explain that. But then, of course, supersymmetry has its own parameter. You may want to go to a deeper theory to explain the parameter in the supersymmetric theory.
For the physics question, okay, I also spent 4 days at this CFHEP. Yeah, 4 days in July. Okay, so and anytime I heard that this big accelerator was now inputting the list of this Chinese academic science, the next 5 year term. So that means that they at the beginning they did not plan to construct or maybe they won't put a high priority to this big factory, big machine. So then I heard that this HEP people find the Qiu Zhentong and like other physicists like Han Tao or Wang Xinlian, they went to see the president of the Chinese Academy, Bai Chunli, and they had a meeting. So then this happened. The meeting happened right after I left. So I'm not sure what's the result of the meeting. Do you hear anything? Because it came there after me.
Okay, I didn't. Well, the only thing I heard from NEMA say the president now is in support of this project. They said initially the president didn't just. When the project was initiated, didn't express his opinion either way. He was looking, but he said he sees such an overwhelming support from many people, and also he thinks it's good for the Chinese Academy. So therefore he seems to be very supportive of this project. But I have to say I heard it indirectly from NEMA, so I don't know whether this is really true or not.
I think initially it's just the 5 years R&D, right? So it doesn't need. I don't think it needs the construction money initially.
I didn't mean construction money. I said whether they want to give any priority to this project.
Yeah.
Whether they want to.
So as long as they have some R&D, okay. I think definitely you have to study the site, then the accelerated technologies. I think the two fronts, they have to get R&D, otherwise the project cannot go.
So actually following Xiangman's question, so what are the other competing projects of the same order in China on the agenda then? So such as, for example, ultimately that's the question, right?
Yeah, as far as I know, for example, there's Juno, the neutrino oscillation, the project, that's basically ongoing. That's competing some of the funding, and also I have several projects actually. The other one is the spallation neutron, and also in Guangdong. So I think in the 5 years term, it depends on how they actually plan out. Initially, definitely there's competitions in funding.
Also, they want to build a larger scale dark matter underground laboratory.
Yeah, but I think that's already ongoing, so that may be, that's definitely the other one, yeah.
I think
the question is scale. I don't think there's except maybe space program. I think those are different scales, scale lower. So this is, Yifang already mentioned 30 billion Chinese yuan, sort of a kind of a indication some time ago, and that seemed to be binding on him. Certainly 30 billion yuan is not, RMB is not enough. But anyway, those things are not addressing his question.
So it's actually the question of whether coming out with the money rather than having the money, they are different products and the price.
I think in Hsin-Chia's presentation, let's say the IHEP director wants to put it into the national budget, the national 5-year plan.
Okay.
So I think it's a different scheme. It's the competition for the 5 years is a different thing.
Yeah, I heard when the president visited IHEP, the Chinese president, he specifically asked that I have to come up with some project after the best, basically 2020. So they need to do something. Also earlier this year, they have some meeting, maybe something like their fiscal society meeting or something. They will present 4 different potential project presentations. One is this one, and the other one is a Taochang factory. I think one is some heavy ion physics. The other is a Z factory. These are the four projects being discussed. The Z factory is just approximately that the 90G is probably can get absorbed into this machine. Then the other just Taochang and heavy ion. From my impression, Taochang may be the biggest competition, maybe because all the older people, all their yuan stuff from doing Taochang, basically they want to do it, keep doing the same things. But most of the young people I can see are more excited about this possibility, as you can easily imagine. So.
But I heard a different opinion when I visited this Chinese University of Technology, Zhongkedao. In fact, because their group is under Zhao Zhenguo, and as you said, Zhao Zhenguo is the mission working on the Taochang factory. And so in fact, his group support the Taochang factory. So now every institution wants to have this big machine. Can
we still spend 5 minutes on physics before we? This is mostly a political thing, I agree. But I think the fundamental question, it was in Ima's slides. He says even if you don't discover anything, right? We enter a new paradigm. But is that good enough for, 50, 100 billion yuan?
Yeah. For ordinary people, I would say it's a hard sell. For some physicists, it will be as important as discover something. But I would admit for politicians or everyday people, it will be very hard sell.
I guess if we still.
The way I asked the question already brings in non-physics, but the question is, how natural is naturalness? And unlike, LHC 14 TeV, we have already discovered the Higgs, so it served a purpose. It's clear that it cannot finish off the subject, but there's no guaranteed discovery even for 100 TeV machine.
Yeah.
So I think that's and I don't think that unless we discover some indication in run 2 of LHC, this problem probably cannot be circumvented.
Yeah, let me just say my opinion. So this is not quoting Nima, but usually what people quoting say how much fine tuning is 1% fine tuning now, and if this 100 TeV machine still doesn't find it's 10 to the minus 4 fine tuning. This probably doesn't sell well with people. Just say why is 10 to the minus 2 is okay, or 10 to the minus 4 not okay. But in principle, we know this fine tuning does exist. We know quantum correction exists. We believe quantum field theory. We also see quadratic divergence in other places like pi plus pi zero mass difference or KK bar mixing and so on. So this is a question. Now, of course, the fine-tuning naturalness argument is just a probability argument. Just say how probable is it. Maybe we are unlucky. We are just in this 1% tuning case. Just if you you have 99% of chance finding something and 1% not finding, but you are just in this unlucky 1% case. It's always possible. But I think this is a risk one has to take. In fact, not just in this field, in any field, there's no guaranteed success. The only difference is that the money is huge. But I think as a whole, we have to decide. That's if we go from LHC to the 100 TeV machine, that's another 2 order magnitude. That is, again, the 99% coverage. Maybe we are unlucky again. We are again in this 1% category. It's always possible. But we cannot use the past failure to predict the future failure. I don't think that's right, because we have 100%, we have a 1% tuning. Therefore, we don't understand hierarchy problem. Let's throw this problem away. I don't think that's the right attitude. The argument maybe use dim red, then we don't see the quadratic divergence. I don't think that's the right argument. So that's my point of view.
So is there some non-collider related supporting argument for building a 100, well, basically setting the scale at 100 TeV as opposed to say 50 or 20, or some astrophysical observation that's supporting the can we make a case for 100 TeV to be the right one?
100 TeV is mostly just a round number. In fact, what China is doing, right now their plan is 50 kilometers. If you really do a 50 kilometer ring, you cannot go to 100 TeV, maybe just only 50 TeV. Of course, basically, right now we have LHC at 14 TeV. Every time you probably can jump by at the most 1 order magnitude. I don't think technology allows you to really jump by 2 orders magnitude at a time.
So that's to do with the construction of superconducting matter.
No, just I think there are many different things. In terms of the energy, it depends on the strength of magnet and the size of the tunnel, basically just proportional to these 2 factors. but in detail, there are probably, I think the experimentalists may have better answer than I do. Basically, if you want 1,000 TeV collider, you probably have to do the 100 TeV collider first before you can do 1,000 TeV collider.
There is no overwhelming reason why we need one.
There are different physics cases may want the different things. In fact, some of the case may even want some physics case may want 200 TeV, maybe better than 100 TeV, but that's maybe a case by case.
I saw this is limited by the current technology.
Well, is any future LHC planning contingent on this part? Like, does this be taken into consideration?
In the future, LGC so far is up to higher velocity LGC to be 2025, right? And I'm not sure what's the next.
High energy LHC means 16.
So not a real change.
Yeah, it's not a big change.
Otherwise, you need a new tunnel. I think.
It basically is constrained by the tunnel size. So the 100 TeV actually, I remember this is more than 10 years ago, and the U.S. Fermi has a study, right? Build a ring from Fermi all the way to Chicago, Lake Michigan, and that's gives us I think between 60 to 100 TeV level, and so at least that kind of civil construction that time, if you use so-called the conventional way, and it's like 100 meter underground the depth, it looks like doable, and of course I think that one was dead later on in US, but at least technology-wise, looks like people already got bought in. So this is renew this. I think in terms of building the size of that kind of size of tunnel, people think that's doable.
One can also
View it this way. SSC had, I think, like 83-kilometer tunnel, 40 TeV. So with a similar sized tunnel with the development of superconducting magnets, 100 TeV is feasible. That's a partial answer to where 100 TeV comes from. It is sort of projecting that if you are very aggressive on magnet technology, you can go further. Okay. But anyway, the size of the tunnel is really coming from SSC. So Yuting, are you satisfied with anything we said? But I think if we're sitting here not discussing physics, okay, likely. Okay, so Status has a comment.
So I think you kind of made my comment before I made it. So I think what we're after now, after we discovered the Higgs, probably Higgs, is we try to understand. I mean, we want to try to understand what makes the Higgs potential. So whatever new, I think, physics you get, supersymmetry, compositeness, or whatever, you have to make sure that somehow the new physics creates the right Higgs potential, right? So, and usually this new physics involves new particles, new states, etc., etc. So, the true hope we all have is that when you go and build this new machine, this new particle states or whatever evidence for this, you will try to understand basically how this is happening by first observing new particles, new states, etc. We may be unlucky, as we all discussing now, and because of statistics or whatever, we don't see anything if we build this machine. I think I fully agree with you, George, that, and I'm very skeptical here that we cannot argue for this machine before we take new data, the next data from LHC, and hopefully start seeing the first evidence of something that we probably don't understand what that is, but if this happens, I think then the road is open. But if this doesn't happen, I don't believe someone will go build this machine to do bread and butter, standard model physics or heavy iron, or I think that's my opinion. I think we have to see something soon.
I think you have to look at the strategy or vision. If you just build a Higgs factory, there's already IOC. If you shoot straight for SPPC, it's like moonshining, okay? So even if we don't see any, The critical thing, I agree with you, is in run 2, if we don't see some indication the first 100 femtobarns, life is getting tough. But that I don't think is a showstopper for a 100 TeV machine. So I appreciate staying on physics, but this kind of planning cannot be just known unknowns, or I don't know, the Rumsfeld word. So let me give my view roughly on this. When I first heard this basically 2 years ago, I liked it very much because I can see the strategy. So you have a Higgs factory, in a certain sense it's competing with IOC. That's a good thing. But then, you know, if you get the tunnel right, then you get the discovery machine afterwards. And then, you know, the timing is right because I think it was in Yifan Wang's slides, what he presented at Fermilab. It will be a pity if the world misses this chance, not just China missing the chance. So there is some level of pompousness, yes, but I think Yifan is working hard to what I call to get the ratio of funding of HEP from the Chinese budget. But given that China is becoming the largest, not dominant, the largest world economy, if world HEP misses out on that funding, it will be a pity. So this is my reverse way to address your issue. For that, we cannot sit and wait and say, oh, let's see if LHC Run 2, etc., shows us the way or not. For this kind of planning, you just have to go ahead. So I raised that issue myself, saying that I doubt we have a foolproof this thing like the Higgs itself for this 100 TeV machine. So that's also why I said that the scale is set by experience and accumulated experience both of the SSC and then the magnet. So this machine is doable for the world, and probably China has the funding. That's why I felt it was a good thing. And you know, for myself, as I told people, I support both IOC and this type of machine because I want big facilities in our region.
Okay, you brought it up here.
Turn it on the bottom.
Turn it on.
Okay.
Push up.
Okay, so since you brought it up, because I wanted also to comment on that, the interplay between ILC and the 100 TeV. I mean, for the ILC, I think it's a staged proposal, as we saw today. Starts from 250 and goes up to 50 GeV. This has a strong physics case, right? So I wanted also to ask the panel, what do you think about this interplay? Because if the ILC happens, it will be also in an overlap with the phase 2 of Atlas and of LHC. And if we want to start something in China with 100 TeV, this also, the plan also tells you that this should start after 2020. Yeah. So I'm trying to say that I still believe there is a difficulty here because the LHC case and the ILC case are quite strong given what we know now. But then it's absolutely nice to have the 100 TeV, but I see it as very difficult before we have more information.
So that's why you won't get built until what, 2030?
Sorry?
2040.
20,
Data take.
data taken 2042, right?
Yeah, but
Is
you have to start very early, right?
No, the construction is somewhere in the 2030. If you want them to do it.
No, I think you talk about E plus E minus machines.
Yes,
That's
I
why
mean-
you start early.
Okay, yes. E plus minus is, according to what I saw there, was 2020.
Well, yes. 2028. 2028.
2028 physics.
Yeah.
Yeah, physics.
Physics 2028, and that's their dream scenario for E plus E minus, start taking data.
So there are periods right now. You can wait. In some sense, these are two competitions, right?
Yeah.
IOC and this circular machine.
Yeah.
And depend on how they evolve. And there's still, some time period. And